Design patterns. Every senior developer knows them. Every interview asks about them. But most tutorials make them sound complicated when they're actually simple ideas. In this video, we'll cover 8 essential design patterns: singleton, factory, builder, adapter, decorator, strategy, observer, and dependency injection. For each one, a simple analogy, clean Java code, and what goes wrong if you skip it. Let's get started. So what exactly is a design pattern? It's a proven solution to a problem that developers keep running into. Think of it as a recipe. You don't invent a new way to bake bread every time, you follow a recipe and adjust for your taste. Same idea. Design patterns are blueprints. They're not copy-paste code. They're approaches. And they work in any language: Java, Python, C++, doesn't matter. Today, we go through 8 patterns. 3 creational, how to create objects smartly. 2 structural, how to organize classes. And 3 behavioral, how objects communicate. Let's start with the creational patterns. Creational patterns deal with object creation. Instead of using new everywhere and creating a mess, these patterns give you elegant, controlled ways to create objects. 3 patterns here: singleton, factory, and builder. Singleton. The simplest pattern to understand. The rule: only one instance of a class should ever exist. That's it. Think of the president of a country. There's only one at a time. You don't create a new president every time someone needs to talk to the government. Same with a logger. Your entire application needs one logger, not 50 copies writing to different files. How does it work? Make the constructor private, so nobody outside can call new. Then provide a static method, getInstance, that creates the object once and returns the same one every time. Here's the classic singleton. The constructor is private. Nobody outside can write new logger. The static field, instance, holds the one and only object. The getInstance method checks if instance is null, create it. Otherwise, return the existing one. So no matter how many times you call getInstance, you always get the same logger object. One object. Shared everywhere. What happens without singleton? Multiple loggers writing to different files. Inconsistent logs. Wasted memory. A debugging nightmare. Factory pattern. The idea: the client shouldn't worry about how objects are created. You just say what you want and the factory gives it to you. Think of a pizza shop. You walk in and say, "Give me a margherita." You don't go into the kitchen, pick the dough, add the sauce yourself. The counter takes your order, and the kitchen handles the rest. Same with factory. The client says, "I need a circle shape." The factory creates and returns the right object. If tomorrow you add a triangle, the client code doesn't change at all. Only the factory knows how to create things. Here's the shape factory. We have a shape interface with a draw method. Circle and square both implement it. Now, the shape factory has a static method, get, that takes a string and returns the right object. Client just calls shapefactory.get with circle and gets a circle. No need to know about the circle class directly. Want to add triangle later? Just add a new class and update the factory. The client code stays exactly the same. Without factory, the client would write new circle, new square everywhere. If class names change, you'd have to update every single file. Factory centralizes that. Builder pattern. When an object has many fields, say 10 or 15, using a constructor with 10 parameters is a nightmare. Which parameter is which? Easy to mix up. Builder solves this by letting you set each field one at a time, with clear method names. Think of ordering a custom burger. You say, "Add cheese. Add lettuce. Add extra sauce. Hold the onions." Step by step. The builder pattern works the same way. Each method sets one field and returns the builder itself, so you can chain calls. Finally, call build and your object is ready. Clean and readable. Here's the builder in action. Person has a private constructor, you can't create it directly. Instead, you use the inner builder class. Call name, pass a value. Call age, pass a value. Each method returns this, the builder itself, so you can chain them. Finally, call build, which calls the private constructor and creates the person. Clean. Readable. And if person had 10 fields, you'd just add 10 builder methods. No giant constructor. No confusion about parameter order. Without builder, imagine new person, open parenthesis, Ram, 25, null, messy and error prone. Builder makes it human readable. Structural patterns. These deal with how classes and objects are organized, how they connect and work together. Two key patterns here, adapter and decorator. Adapter pattern. You have an existing system that works perfectly. Now, you get a new library, but its interface is different. The methods have different names. Do you rewrite your entire system to match the new library? No. You write an adapter. Think of it like a phone charger adapter. Your US plug doesn't fit an Indian socket. But a small adapter in between, and everything works. Same idea in code. The adapter wraps the new library and makes it look like your old interface. Your existing code doesn't change at all. One thin wrapper, and two incompatible systems work together. Here's the example. Media player is our existing interface with a play method. MP3 player implements it. Works great. Now, we get a new MP4 player library, but it uses a different method named playMP4, not play. Our system expects media player. So we write an adapter, MP4 adapter, that implements media player and internally calls MP4 player's playMP4 method. Now, any code that works with media player can use MP4 adapter seamlessly. No changes to the existing system. Without adapter, you'd need to rewrite every file that uses media player or maintain two separate systems. The adapter saves you from all of that. Decorator pattern. You have a base object and you want to add features to it without modifying its code. Think of a coffee shop. You start with a simple black coffee. Then you say, add milk. Now it's coffee with milk. Add sugar. Now it's coffee with milk and sugar. Each addition wraps the previous one. That's exactly how decorator works. You wrap an object inside another object, and each wrapper adds one feature. The beauty. Without decorator, you'd need separate classes, coffee with milk, coffee with sugar, coffee with milk and sugar, coffee with milk and sugar and caramel, the list explodes. With decorator, you just stack wrappers. Simple and clean. Here's the coffee decorator. Coffee interface has two methods, description and cost. Simple coffee returns coffee and costs 5. Now, milk decorator also implements coffee, but wraps another coffee object inside it. When you call description, it calls the inner coffee's description and appends milk. When you call cost, it adds 2 to the inner coffee's cost. So, new milk decorator wrapping simple coffee gives you coffee, milk and cost 7. Want sugar too? Wrap it in a sugar decorator. Stack as many as you want. Each decorator adds one feature. Clean and extensible. Behavioral patterns. These define how objects communicate and distribute responsibility. 3 patterns here: strategy, observer, and dependency injection. Strategy pattern. Imagine Google Maps. You enter a destination, and it gives you options: drive, walk, or cycle. Each route uses a different algorithm. But the app itself doesn't change. It just swaps the routing strategy based on your choice. That's strategy. You encapsulate each algorithm in its own class. The context, say a shopping cart, holds a reference to the current strategy. Need to switch from credit card to PayPal. Just swap the strategy object. No if-else chains. No modification to existing code. Just plug in a different strategy, and the behavior changes instantly. Here's the strategy in action. Payment strategy is the interface with a pay method. Credit card and PayPal are two concrete strategies, each with their own pay logic. Shopping cart is the context. It holds a payment strategy reference. You set the strategy and call checkout. Want credit card? Set credit card. Want PayPal? Set PayPal. The shopping cart code never changes. Without strategy, you'd write if payment type equals credit card, do this. Else if PayPal, do that. Every new payment method, another else if. Giant chains that grow forever. Strategy eliminates all of that. Observer pattern. Think of YouTube. You subscribe to a channel. Whenever the channel uploads a new video, you get a notification. You didn't have to keep checking manually. The channel notified you automatically. That's the observer pattern. One subject, the YouTube channel. Many observers, the subscribers. When the subject's state changes, all observers are automatically updated. The subject doesn't need to know the details of each observer. It just calls update on everyone in its list. Loose coupling. If a new observer subscribes, the subject's code doesn't change at all. Here's the news agency example. Observer interface has one method, update. News agency is the subject, it keeps a list of subscribers. When you call publish with some news, it loops through all subscribers and calls update on each one. News channel is a concrete observer, it prints the news with its channel name. Subscribe CNN and BBC. Publish breaking news, both channels receive it automatically. Without observer, you'd manually call each channel, hard-code it. Add a new channel. Change the subject's code. Tightly coupled. Observer removes that coupling entirely. Dependency injection. A fancy name for a very simple idea. Instead of a class creating its own dependencies inside, you give them to it from outside. Think of a restaurant. You don't go into the kitchen and cook your own food. The waiter brings it to you. That's injection. In code, if your class needs a service, don't write new service inside the class. Instead, accept it through the constructor. Why? Because now you can swap it easily. Need a mock for testing? Inject a mock. Need a different implementation for production? Just pass it in. Frameworks like Spring Boot automate this entirely, you just declare what you need and the framework injects it. Here's the difference. Without dependency injection, the client creates its own service with new. Hard-code it. If you want to test with a mock, tough luck. You can't swap it without changing the class. Now, with dependency injection, the client accepts a service through its constructor. It doesn't create it. Someone else, the caller or the framework, passes it in. Want to test? Pass a mock service. Want a different implementation? Just inject it. The client class never changes. This is why every major framework, Spring Boot, Dagger, Guys, is built around dependency injection. It makes your code flexible and testable. Now, the million-dollar question, strategy looks like factory. Both use interfaces. Both have multiple implementations. So what's the difference? Factory decides what object to create. You call the factory, it gives you the right object and you are done. Strategy decides how to do something, and you can change the algorithm at any point during runtime. Factory is a one-time decision at creation. Strategy is an ongoing, swappable choice. Factory answers, which class should I instantiate? Strategy answers, which algorithm should I use right now? They look similar on the surface, but they solve completely different problems. Quick reference. Singleton, one instance, shared everywhere. Factory, client says what, factory handles creation. Builder, construct complex objects step by step, no messy constructors. Adapter, make old code work with new interfaces. Decorator, add features by wrapping objects, no class explosion. Strategy, swap algorithms without touching context code. Observer, one change, all subscribers notified automatically. And dependency injection, don't create dependencies inside, inject them from outside. 8 patterns. Each one solves a real, everyday problem. Learn them, use them, and your code will be cleaner, guaranteed. That's a wrap. 8 design patterns explained with analogies, clean Java code, and real-world reasoning. If even one pattern clicked for you today, hit that like button. Subscribe for more deep dive tech videos. And drop a comment, which design pattern do you use the most in your projects? I'd love to know. See you in the next one.